Gaia, it was it?
Yes.
Yes.
Perfect.
Okay.
So, hello to everybody. I'm very happy to introduce David Brettel. He is the Chief Scientific Officer at Leeds Teaching Hospital, NHS, Trust UK. He also has a role leading on quality in digital pathology at NPIC, National Pathology Imaging Cooperative. Much of his experience and knowledge come from his background with implementing digital radiology over 30 plus years of experience in the field. That knowledge and skills are being transferred to digital histopathology. He has led on the design and implementation of many QC tools and standards for digital pathology in the UK.
I don't see any slides.
No, I just introducing the relators. Yeah. And so this experience with tools and standards for digital pathology has been replicated across the Bigpicture consortium. Then we have Dr. Eli, Pai, and Katrina Dunn that work with David in the Quality for Digital Pathology group at NPIC. And today in this webinar, they will give us a detailed understanding of some of the elements in the digital pathology imaging chain that contribute to variation in the digital image, including staining, scanning, and display, and how all these elements can affect image quality. So the topic is super juicy and super interesting for me, and so I'm super curious to hear.
Thank you.
Can you share your presentation, David?
Thank you for the introduction. Can you hear me okay? And
clear and loud.
Hopefully you can see my screen.
Yes.
Perfect. So thank you all for joining us today. This is a webinar around the NPIC activities, but as mentioned, we're also heavily active in Bigpicture. So everything here will hopefully find its way into Bigpicture in due course. So obviously this presentation is going to be by all three of us, because we each focus, if you like, on different areas of quality, and it's going to be around quality more than the other activities. So some areas I may skip over and some I will talk about in less depth, but be assured everything is what we're interested in, absolutely everything. So just a little outline. I'll give a quick introduction to NPIC for those who don't know. We'll then go through the 7 stages of whole slide imaging workflow, looking at some of the challenges in those areas as we go through. We're going to then ask you to provide your opinions. We're trying to make this as interactive as we can, which is difficult on Teams, but hopefully we'll be able to use a Menti survey. There will be a QR code and a web link on the screen, and if you can participate in that, that'd be great, because we're actually using opportunities like this to gather the evidence in itself for the need and the gaps in quality in digital pathology. So every talk we do, we're trying to get this qualitative data, this big landscape of what people are doing. Then we'll just do a little bit about Bigpicture and have questions at the end. So what is NPIC? So NPIC is called the National Pathology Imaging Cooperative. We actually started out being the Northern Pathology Imaging Cooperative, but we deliberately called it Northern so we could change it to national, because our aspirations from the beginning were to be national. So we are a government funded from the UK government Centre of Excellence. There were 5 set up in 2019 to look at a platform for digital and AI in the NHS. This is interoperability funding, and the aim of this funding is to allow us to grow and scale at pace digital pathology. And I think that's one of the exciting things about this project. You can see on the map on the right, we started out with just a blue area. We then went to the red area. We then went to the red, blue and green area, and now we have the black area. And within that that national profile, we also have 2 important networks. We have a sarcoma network and we have a pediatric pathology network as well. So not only do we have the breadth and depth for, I would say, sort of general operational pathology, but also for specific areas as well. So the aims are to enable the use of digital pathology, develop, evaluate AI, and create a platform for research and innovation. So we cover the whole range of digital pathology, and this is really important. It's the end to end is really important. If we miss one of these stages, then we've got a problem. So obviously, all the way from the pre-analytical all the way to the AI evaluation in itself. We have a really nice technology stack here, and you can see how that works up with our partners who we've been working with. And we've specifically and importantly focused on being vendor neutral. So the concept is that anybody can put data into our repository, and anybody can access that data. And that's really important, that we don't have a closed system. So all the way from all the range of scanners, all the way to the range of AI tools and packs, they all are centered around that vendor neutral archive. So just a few numbers to give you a scale. When we did the regional deployment, 238 pathologists, 6 million people, 48 scanners, 15 trusts, 2.4 million images per year. So it's quite a feat, and that's before we went truly national. So much to do.
Sorry, someone is saying that the screen is not shared.
I
can see it.
You can see
it works for me.
There was an old comment from when you were still presenting,
Okay.
Kaya.
Okay.
Sorry.
Oh, thank you. So like I say, this is a platform for many applications, from clinical diagnosis, supporting that national network, through to the development of digital and AI, and then promoting this national research and innovation platform. And I think one of the exciting projects we're working is in genomics on the 100,000 genome project in the UK, and we are currently working with them digitizing their slides, so they not only have the genome data, but they also have the pathology data to go with that. And of course, nobody does work at this scale on their own, and we have many partners and in the NPIC, and these are the official partners listed here. So, forgive me, there's a little bit of duplication in here. So moving on then to the 7 stages of whole slide imaging. So as I said, some of these I will skip over quickly, and some we will go into depth, and Hayley and Kat will take over the relative parts as required, and I will move their slides for them. But we start with recognizing that there are these sort of 7 pillars, 7 stages of whole slide imaging workflow, the pre-staining all the way through to the AI. Now, the pre-staining is a tricky old area. It includes sample preparation, trimming, embedding, sectioning, but there's, we believe, one of the biggest areas of error in the generation of the slides, and up to 40% variation in there. We're not looking at this area at the moment, and you'll say, why not? We're looking at sectioning. We've got tools for slice thickness variation, because that's something we can do, but it is very complex, and we recognise that probably the most important thing is to look at the quick wins where we can. Once we've got that growth and momentum around quality, we can then build on that, and then we can start to address even the most complicated areas. And I think it's actually a truism that it is so complex that nothing has been done to date on this. There's very little being done, and there's a lot of variability. But one area that we're particularly interested in is stain variation, because as you'll see in a moment, that is a large area of variation, but it's, we believe, relatively accessible. So moving on to staining, I'm going to ask Kat to take over now, and I'll move your slides on for you, Kat.
Thanks, David. Next slide. So staining, which includes tissue staining, cover slip mounting, slide inspection and storage, and we estimate this has about 40% variation. Next slide. So we have tissue on a glass slide, and next we apply histochemical stains to these pieces of tissue on slide. And this is really important for analysis. As you can see here, there's a whole range of histochemical stains that we can use, but the most commonly used stains are hematoxylin and eosin, as I'm sure you're all familiar with. Slides are stained with H&E all over the world, and they account for about 80% of all slides stained. Next slide. So H&E staining in pathology is variable, and this can be down to a whole number of reasons. And this can be, for example, dilution of stains as you go about staining over the course of a day or a week. But it can also be through using different types of H&E or different H&E staining protocols. And these can vary vastly, as there's no set standard for the use of H&E, despite its ubiquity in pathology practice across the world. So here you can see an example of how much H&E slides can vary in the real world. These are all breast tissue stained with H&E, but in different institutions. And you can see a dramatic difference between them. And although us humans can tolerate a certain level of variation, algorithms are less tolerant and they can be thrown by this variation. Next slide, please. So in our early work, we've investigated the impact of induced stain variation on automated nuclear counts. We stained liver tissue according to a normal laboratory staining protocol, but we also stained it, we understained and we overstained some tissue. We then applied automated nuclear counts to regions on these tissue, and you can see in the boxes at the bottom, where the blue dots are is where the automated count has detected nuclei. You can see the difference between the under, the normal and the overstained. And then when you look at the numerical counts from the nuclear count, you can see there again, so for the understained slides, they were less than half the count that we found for the normal stained, and then the overstained were about 20% extra. So this is just a simple example of how stain variation can impact upon image analysis. Next slide. The impact of stain variation on AI in the real world is in the literature, and we can use methods such as colour normalization, where we normalize images to a target image with optimal staining. And this technique of standardizing colour can improve accuracy of AI by more than 20%. We can also use deep learning, where we introduce variable images in the training data so that the AI can be more robust to variation, but we still find batch effects where images are inherently biased between institutions. Next slide. So despite the amount of stain variation that we see in practice, it has been widely tolerated to date, and current methods of quality control are subjective observations of stained control tissue. And so in order to improve quality assurance of the staining process, NPIC have been developing an objective method of quality control to quantify H&E staining in pathology. And these are called Tango quality slides, that you can see in the image here on the right. So a Tango quality slide consists of a normal pathology glass slide, and on it is a label, and the central circle there contains a stain responsive biopolymer film. And importantly, this biopolymer film has a known thickness, and this provides an absolute for the quantification method that we're undertaking. Next slide. The biopolymer responds linearly with stain time. So you can see in this graph here, there's total absorbance along the y-axis, which is a measure of intensity, and stain duration along the x-axis. And here you can see its response with hematoxylin, which is along the red line that you can see, with eosin, which is the green line, and with H&E combined, which is the blue line. And there was a really strong linear response with respect to stain time, with correlation coefficients of around 0.99. Next slide. So you can implement Tango quality slides really easily in your lab. It's really quick and easy to implement. You can take an unstained slide, bob it in your staining instrument, and this can be alongside other clinical samples. You then remove the slide and it has been stained, and you can measure that central circle to provide a measure of your H&E. And at the moment, we're measuring this spectrally in our quality lab with a spectrophotometer. However, moving forward, you can see a little image here of a mini scanner that Professor David Brettel has actually developed himself. And the idea is we can have this right next to your staining instrument. So you take the slide out of the stainer, you bob it into the mini scanner, and you get an immediate feedback as to whether your staining was within your set parameters. Next slide. So we have implemented these slides as an initial study in 8 labs across the UK, where they stained 4 Tango quality slides alongside some tissue control slides as well over a period of 2 weeks. And here you can see these are images of the Tango quality slides over one of those weeks. And you can see a little bit of variation within each lab, but massive amounts of variation between the labs. Next slide. So the results here are plotted on a box plot. Again, along the y-axis, we have total absorbance, and along the x, we have the different labs. And each box here represents a different lab, and the colour of each box represents the median colour value that we measured. And on average, between the labs, within the labs, we found about 10% variation. However, between the labs, this is much more dramatic. So, for example, between lab 2 and lab 6, there was actually 91% difference. And then when you look into their staining protocols, lab 2 actually stained their slides for more than 4 times as long as lab 6 did. Next slide. And so this is just an example of how we could reduce variation between the labs. If we were to aim for a similar intensity, you have the potential to reduce variation between labs by 30%, thus providing better standardization of the resultant images. Next slide. Improved stain quality control will not only make staining more consistent, but it will also offer feedback to the lab, optimizing the use of reagents. The consistent images will be more valuable for archives, and this in turn should speed up AI development and efficiency and allow for better portability of algorithms between institutions. Thanks. I'll send you on to Hayley now.
Hi everyone, so my name's Hayley. I also work with David and Kat. So I'm going to go through some test objects that have been developed in the scanning part of the workflow. Next slide. Okay, so the first one is a Sierra test object. It was developed between FFEI, a company, and NPIC in Leeds. And this is a colour characterisation tool. Some of you in Bigpicture may already be familiar with this. We've already started to circulate some of these slides within the people who will be contributing slides. And what it is a series of the biopolymer that's been stained with pathologically relevant clinical stains. The same chemicals you use in your stains in your path labs, we're using to stain these patches. So the colours are absolutely representative of those colours you're seeing in your tissue samples. The top bit represents the different ranges of H&E at different intensities that you might have. And other stains that you might use in other specialities are represented in the bottom half of the slide. And the next slide. So this tool was actually developed for colour characterisation of images. So if you look on the left, that is an image that you might get off a scanner. So as scanners sometimes apply their own colour profiles. Sometimes some of the way it's scanned might change the colour. Turning it from, through a microscope into a scanner will affect those changes. But what we can do is, because we know the colour of those patches as they look down a microscope in real life, we can then calibrate that image, because we've also scanned the Sierra slide, so we can make that image look much more like what it would do down the microscope. So that's what Sierra can do. And Emily, if you press next slide, has done some work within NPIC, and the paper's found there if you want to find out more. And she's asked the pathologist, do you prefer these calibrated images? And overwhelmingly they did. But what we've done more recently, next slide, is we've used Sierra to look at the colour across different scanners. There's a lot of different whole slide images on the market at the moment. And if you take that single glass slide and put it into different scanners, you'll get 5 different images, for example. And we want to know how different they were. So we did this, next slide. So we took 5 different scanners, different makes and models. So completely different companies make these scanners. We use the out-of-the-box profile for 40 times magnification and the default settings for tissue scanning for all of them. Next slide. And this is the data we got with Sierra. So each of the box plots is a different scanned image. Along the bottom, you'll see A, B, C, etc. The letter represents the scanner that was used, and then we scanned it twice, so they're duplicate images. So the replicated images are very consistent, but between scanners, we're seeing differences. And what you're looking at is each of those coloured dots represents each of the patches on Sierra. On that y-axis at the bottom, where it says 0, that would be where there's no difference in colour between the image that was created and the ground truth colour of that patch as we know it as measured on our spectroscopy machine. So as you go up, there's a greater colour difference measured in delta E, and the higher up, the greater that colour difference. And visually, as humans, anything above 5 is visually quite different. So there are a lot of colour differences, and they do change between the scanners. Okay, next slide. But it's not just about colour. What about the contrast of the image? Next slide. So NPIC's also started to develop other test objects. We've got some test objects with neutral density filters on. So these are filters that absorb red, green, and blue light equally. And they just change the amount of light that they absorb. Next slide. So when we put a slide with these in through the scanners, this is the data we get. So along the bottom, again, you've got your 5 different scanners and your replicated data, 1 and 2. This time on the y-axis, at the bottom is the grayness of the patch on the scanned image. And what you can see is some of those scanners on the right-hand side are making those dark patches look a lot brighter artificially. And the different spacing between those different patch colours is kind of stretched and skewed, and all scanners seem to do different things with that, with the sort of different contrast that they're getting. So if you press next slide, if we plot that same data with transmission of light along that bottom axis, some scanners, so the different scanners are different coloured lines, have a very linear relationship with contrast, but some of them have kind of changed that relationship into a more curved relationship. Okay, next slide. What about resolution? We've thought about contrast. There's loads of different things that we need to look at. So we've developed a test object for that as well. So next slide. So this one was made with microscale lithography. So there's a series of what are called line pairs distributed across the slide. And what they are very, very accurately deposited marks on the slide that are a series of lines. They go from big, thick lines, about 300 micrometers thick, down to 1 micrometer thick lines. And these are replicated at different positions all across the slide. Next slide. So what happens with these is, as the lines get closer and closer together and thinner, what happens is sometimes they just become grey in the image. And this can be because they're out of focus or they're beyond the resolution limit of the scanner. We can measure what's called a percentage contrast value for each of those different sized line pairs. And then when we plot that, we can compare the scanners. So if you press the next slide, this is what we get. So on the right there, each different coloured line is a different scanner. So none of the scanners could replicate the line pairs, especially the really small ones, as you're going right across the bottom of the image. But there was a huge difference between the scanners and how well they could replicate that. Even sometimes with some scanners within one image, it would replicate some of the line pairs well and some of it wouldn't. Our next generation one of these will be able to distinguish between focus and resolution limits. But for now, I will pass you back for the next stage of the process.
So after, of course, the digitization, there's a whole process about the quality control of the produced image. We need to make sure that we don't have an out of focus image or a dirty image. There's a lot of work done on this. It's not an area we're focusing on in NPIC, but there are many tools available, commercial software tools and even shareware available tools to do this quantification. What we're very keen on, and I'll mention it later, is of course capturing that information, having a proper ontology of the errors and a common ontology, so that we can look at data retrospectively and look at the variability of that quality. So before we have AI, of course, we are still required to report off these images. And of course, we don't have the microscope. We now have a monitor and a display. And this is a really important area. For me, a display is not a display. It's a human interface to the digital image. It's the point of contact between us and that data. And there's still quite a bit of uncertainty about the importance, the requirements for displays. That there are only a few specifically solved for digital pathology, and there are no real clear guidelines on specifications or QA requirements, and those that we have are either variable and certainly not established. So there are many technical factors that affect the performance of a display: resolution, response time, color space, refresh rate, pixel morphology. This can result in a wide range of product specifications and, of course, cost. And I guess those of you who have looked to buy a monitor will be quite surprised how expensive they can be at the high end. And each has their own varying display performance. So this leads to confusion, and as you can see in this image, we're all used to this. When we go and buy a television and we go into a store, and then you will have a whole range, and you look at them and you pick the one that you like. You pick the one that looks best like the image that you can be comfortable with. And here you can see the range going from the smaller monitors on the top shelf to medium size in the middle and big monitors on the bottom. And you can see there are brighter monitors, darker monitors. There are those that have got saturated, those that are more comfortable to look at. So we know this is a problem. We have this in our consumer life, and not surprisingly, this is a problem in our medical life as well. So here we have a range of 8 monitors used for viewing digital pathology images. All of these images were acquired with the same camera settings. The monitors were set with nominally the same settings, and we ensured scale and resolution was as close as we could get it as well. So to all intents and purposes, it is the same image, and you can just see the variability. And importantly, and I will repeat this later, this is compounded on top of that variability that Kat pointed out earlier, and the variability that Hayley pointed out as well with the scanners. So you have a different scanner, different staining protocol, and a different display. You can end up with quite a radically different image from another colleague who may be looking at a different scanner and a different staining methodology and a different display. So I think that's really important for us to emphasize that. And it is important, and I'm really pleased to see colleagues also recognising this is important. This is a paper from 2020, and I love this quote: "We proffer that choosing one's display for digital pathology will be equally as important as currently selecting one's microscope." So there are some standards out there. We have a number of years, we've had some of the professional bodies have tried to establish standards. I mean, one problem, of course, is standards change. The market is very much driven by consumer demand. Who would have thought that 4K would have been the standard for a display on our desktop a few years ago? And certainly some of the new technologies coming out, like organic LEDs and quantum dots, are producing greater contrast and colour range. So these standards will be difficult to keep on top of. In the UK, we produce guidelines for remote reporting during periods of exceptional service pressure, COVID, and we set out a minimum specification ourselves that we felt was safe, and this was to allow pathologists to work from home. And you can see we set a minimum level there of 350 candelas, that's the brightness, a resolution of 3 megapixel, although that's quite low, and also larger than 24 inches, which is also quite low, but this is the minimum level. So there are some companies now starting to sell displays specifically for digital pathology. I've listed a few there. Most, though, have been repurposed or modified versions of radiology monitors, which is a very mature market. There are many dedicated products for digital radiology, and logically there's been a migration of those technologies into digital pathology, and they cover a wide range of resolutions, all the way from 2 to 12 megapixels, which is amazing. And there's a nice picture there showing a monitor that is sold with a dual mode. It's a dual mode of mammography, which is one of the highest demanding areas for digital radiology, and also for digital pathology mode. And there is a FDA approved, I put approved in quotes because it's the Barco monitor, but it is FDA approved for certain conditions, and I've listed the conditions there on the bottom right. This is what has been validated, I guess, is quite specific. So if you don't meet those, then I guess they would say that you fell outside that validation. However, I would say if it can meet all of those conditions, that system is clearly a good display, and meeting the standards and requirements across a range of scanners and a range of softwares. and it is sold for that purpose, because being sold for a purpose is really important. But they're also obviously not going to be the cheapest. I mentioned before a range of prices, and there may not be affordability there, and there may not be availability in your institution. So we came up with this idea of banding, and this is basically borrowing the idea from consumer magazines, where you can have a valuation of a car, for instance, and they would say here's a luxury car, here's a medium-sized compact, here's a SUV, and within those will be varying specifications. You will have your entry-level high-end car that doesn't have the sat nav but has the engine and has the leather seats, and then you go to the high spec. So we're all comfortable with this idea of range of products with a range of specifications. So we've tried to capture that with respect to medical devices, where the A plus is the, I would call it the sort of early adopter, the research highest end, technologically what is commercially available, the highest end of that, and that's what we call the A plus, because generally that's not going to be available or affordable for the majority of users, but is possibly for the highest demanding and highest difficulty of cases, or for research. And then you have the A band, which is your high-end monitors, your B band and your C band for the low end. And the reason it's banded is because that technology moves, it changes. So by allowing us to put these into the bands, they can move. So in a year's time, the A1 may be different, but it'll still be an A1. And if I've locked into saying I need a high-end all options display, that will be different in a few years than it is today. And we've populated this banding with current products. This is a little year or so old. It may well have changed, so please take this with a little bit of caution. But it generally lays out the commercial products out there and how they should fit in the product range. And you can see that I've put the C band into red. I think really we would be questioning now whether you should be using technologies of those specifications in any way, shape or form for digital pathology, other than perhaps for quality purposes at the scanner. But even then, I would say, why would you not go for a higher band monitor? Because frankly, the Bs are affordable now. 4K monitors are readily available as well. So alongside the purchasing decision, there's also a strategy that you have to adopt, I would argue, for how you use displays. So the first strategy is glass every time. So that's the safest method of deploying digital pathology, that you always have the glass next to the monitor. You can look at that on the microscope, and that gives you 100% safety and confidence that you've got access to the data. But it's time consuming, it's also costly, and you don't get the benefits. You may as well just look at the glass. But it is absolutely an ideal stratagem for introducing digital technologies and gaining confidence and experience. So maybe when somebody's being validated for viewing digital images, they may for a while, for instance, wish to have the glass there just in case, but certainly not sustainable, I would argue. The other stratagem is to say we will give everybody the best monitor we can. Cost is no option, and that's a problem. Health, no matter where we are, anything related to health is cost strained, so it's unlikely to be affordable. There may be circumstances where that cost is acceptable, and that could be around a risk mitigation or being part of a quality pipeline. It's not necessarily an impossible stratagem, but it's certainly not for health related, hospital related situations. It may be too expensive, but it is certainly a good approach. And the third is probably what I would call the most pragmatic solution, and the one that certainly we look to is almost looking at the use case for each monitor and choosing from the banding the most applicable display to go for that task that you're doing. So you will, though, in my opinion, have to have recourse availability of one of the high-end reference displays, and that is because if you can't see something on display, what do? Well, you can't go and get the glass easily, so you need to be able to go to a high-end monitor and look at it on there. But that does allow a sort of graded use of monitors, and therefore keeps the cost a little bit more modest. And then, of course, within the bands, even within the range of technologies, there's still local preference, local comparison, and I don't think we should get rid of that. I have no problem with doing that, and we develop a technique to basically use a preference study of a range of displays in, put them side by side, put up the same image on each or a range of images, and get your pathologist to score their preference on them. And that way, there's many benefits of that. Of course, one is that you can pick the model that works for you, but you also get that engagement with the technology, and everybody feels like they've had a say in what is bought. So it's more than just a technical issue. This is a culture change issue as well. And just before we move on, I would say, and it's important to say, in my view, if there is a medical device for the purpose, that is the monitor you should buy, because it's being manufactured for that purpose. Using other monitors is possible, but if they've not been purchased for that, manufactured for that purpose, then you're using them effectively off license or out of their scope. A consumer device used for a medical application has to be used with caution. There are circumstances where that caution warrants it, but certainly I would recommend a risk assessment if you were doing that regardless of which display you use. But the safest position would be to say, is there a display that is approved, sold for the specific purpose I have of digital pathology? And if there is, that would be a preference. Doesn't mean you can't use the others if you have good QA. So going on to QA, I think this is really important for us, is if you have good QA, then you can perhaps validate or risk assess against other specifications. So I think that's really important, particularly for home use. So this is a tool we developed. Some of you may have used this and know of this. It's called the Point of Use QA tool for pathology. It's a series of letters. There's 4 letters there in a box, and those 4 letters, you have to repeat them. If you repeat them, then we know that you're performing at a minimum level of contrast discrimination or color contrast discrimination across a range of features, from a bright feature to a dark feature, as you would in a normal image. And these have been set at a delta E, i.e. a perceivable color difference that it relates to just being able to see them. So we can hopefully just see these. Now in a minute I'm going to pop up a different one of these, and Hayley is going to put into the chat a 4, a 3, a 2 and a 1, and if you can score the point of use QA that I put up, and honestly put down how many you got, just for fun, nobody's making any judgment, just for fun, then it'd be really nice to see if there's any variability, and when we've done that, I will also tell you the current failure rate that we have on this tool. So generally, QA, there is little QA specified for digital pathology. Certainly, if you buy a CE marked medical device, that will come with manufacturer's requirements, and that's another benefit of them. They will require quality control, and they will set specifications for that. They will also make sure the monitor is calibrated, and self-calibrated is often built into a medical device, and again, that's a real benefit and importance of that. But there are pragmatic tools that we can do in a QA program. Cleaning the display. It is amazing how many fingerprints there are in the central region of a display where people just point and touch the screen. Checking the minimum contrast, such as using the point of use QA tool, daily, weekly, will give you confidence the display hasn't gone off, or the contrast and brightness been adjusted by error. And then formal testing of the resolution, perhaps color calibration, brightness calibration, checking those settings. If you have a medical monitor, they will almost certainly have those built in, and they will do that for you and do adjustments. So they're a good set, I think, of pragmatic day minima tests. So a daily minimum, I would say, is that it has to be simple for a user to conduct. They need to do this, I would argue, because the viewing conditions can change, the lighting can change, your vision can change. You can take your glasses off. It can be a sunny day or a dim day. So we believe that contrast test is important because it checks all those features. So this gives an example of that variability. The top left is in a darkened room, and you will be aware that radiology colleagues do report in darkened rooms, and you should see all the letters there. On the top right, the desk lamp is on. You start to see a bit of glare on the screen. The bottom left, we've got, sorry, top right was when the room light was on. The bottom left is the room light and the desk lamp, and then the bottom bottom left and the bottom right is with the window and the curtains open. And you can see how they impact on the display and cause distraction. So I think now Hayley is going to come to test. So if you could put 4, 3, 2 and 1 into the chat, and if you can all kindly score these and just put a thumbs up against the score you get of how many you get right. And I'll tell you how many you get right, let you have a few seconds to look at it. So this is hopefully you can see this now. Here are the letters. I'm just going to talk for a little while you all look at them. I'm not going to give you too long. And then I'm going to now tell you what the letters are, and you can count how many you get right. So the first one is X, the second one is an N, the third is an R, and the fourth is a V. So how many you get right, if you can just put your thumbs up against the scores in the chat, and we'll have a bit of fun and see what that pass rate is. So while you're all doing that, I'll carry on and just move on to the final parts of this. Again, in a moment, we're going to be asking you to do Menti. The other areas are metadata. This is really important because it's extracting data from the report. It's also putting in production reports or anything that really matters to the image, including, we would argue, the quality ontology. And this is really important for us. It's work that we're working on in Bigpicture, but importantly, this is work that I think Bigpicture is leading on. We're doing it in NPIC, but Bigpicture is actually leading on this, and there's been some fantastic work from the task force and from the members of Bigpicture towards that. And we're hoping that the guidelines that we put out for slide contributing partners in Bigpicture will have a version 2, and in that will be an ontology of those quality metrics. And the reason for this, of course, is it allows us to filter our data to see how many of our images have faults on them, quality issues on them, but also it allows AI developers to make sure they get a representative distribution of images rather than a serendipitous distribution. They can actually say, I want to get enough with focus issues, and I want to get some with chatter in them, for instance. So computational analysis and AI, wow, that's a big area, isn't it? How do you QA AI? Well, obviously the push at the moment, I guess, is towards transparent AI. Explainable AI is the key term. That would also, we'll need some quality metrics, maybe some outcome-based and test metrics or standardized sets that allow you to quantify it. But actually, we're also in NPIC, we've developed a concept of qualified AI. And qualified AI is actually slightly different to analysis. It's around constraint. It's around saying, if you've used, say, for instance, the Tango quality tool, and you've used the Sierra calibration tool, and you've got a correct ontology of errors, and that is available to the AI, and the AI is trained on a data set that is made up of those constraints as well, then we will guarantee or have a level of success for your images in our algorithm. It's the concept is like credentialing, saying that as long as you've got this in your images and our algorithm has been trained on those limits, then that algorithm will work. And that's one way to get around the variability that we have. So our vision, of course, is that if we drive quality worldwide, then all the images will have that quality, all the algorithms will work, and we won't need to have the concept of a qualified AI. But in the interim, it's a suggestion that that may be a way to accelerate the adoption and use of AI. So we mentioned all the different stages. Just to summarize then, image variation is introduced across the whole pathway. At each stage, errors, variability can be compounded. And again, just going back to the point I made earlier, an error in the pre-staining and the staining and the scanning will just replicate through and compound all the way through to the AI. And no wonder AI has challenges and is finding, it works in some circumstances and not another, because those variabilities are not just errors. They mean that the final image that goes for the algorithm can have quite a dramatic variability. I saw recently a slide of a panda that had been part of an AI from MIT to look at mammals, and it had correctly identified the panda. But added just a little bit, a tiny little bit of noise onto that image, the algorithm suddenly detected a gibbon rather than a panda. So I think it's really interesting that even small changes in data are being reported as causing problems. So we've shown you some examples today of measurable variation. I mentioned that we're looking at all of them. We are. And we have out the Quality Coordination Centre, which is replicated in Bigpicture to improve the use of QA and quality across all the pathways. And so we all benefit from that. So just to close off now, the presentation part, here's the links to NPIC. Feel free to check out the Quality Centre. Feel free to join our mailing list. The QR codes are there. I assume we're going to be sharing these slides later, so you'll be able to get those. And I think Hayley may be putting links in the chat. Also, we now would like to move to the Menti side of the presentation to get your opinions and to capture that. One thing, Hayley, are we going to exclude those who have done it already?
Yep, and we have done this before in the NPIC webinar recently. So if anyone recognises this Menti, yeah, we may at some point collate the information now because it's an anonymous webinar. We won't know who is submitted. So if you do recognise this, please hold back. We already have your opinion. So David, the overall results from your point of use QA, the people who got 4 right were 26, 3 right were 4, 2 right were 2, and 1 right was 2.
Thank you, Hayley. The failure rate that we have online, the online tool, we've had over 3,000 uses of the point of use QA, and the failure rate is around 11% at the moment. 11% of people couldn't see all 4 of the squares, and that is excluding those who we believe were just having a look or just randomly testing. So we only counted those who scored 3. So I think that information that you have there, Hayley, is very informative. Hopefully we've got that captured. Thank you.
Okay, fabulous. Hopefully we still have time for the Menti. I'm going to share my screen. So on screen already is the, can you stop, David, and I'll share mine because I can show things coming up live. Okay, can you see the same slide David was showing? Yeah, okay, perfect. Okay, so if you can go to that website there, menti.com, and enter the code. There are 2 sections to complete, and again, your answers are anonymous. Please feel free to share your opinion. So this is the first question, and we're asking 4 questions of you today. We want you to know how much you agree or disagree with the following statements. So there's 5 of you who've responded so far. I'm going to keep the results hidden for a second, just to let a few more people vote. We don't want to influence anybody's opinion. So I'll wait for a few more to tick in, and then I'll share the results. And then once you've answered this question, it will automatically go on to a second question, which is a word cloud, where we're asking you what you think is the current priority at the moment. So I'll move on to that in a minute. Okay, so we're on to about 13. Let's start sharing. So please keep continuing to add your data. We will continue to collect this data. So yeah, a lot of people do think there is a problem with the amount of image variation currently, and that computers, people aren't sure if they're able to compensate for that image variation. And we asked a bit about if we've taught you something today about the webinar. So thank you very much for your replies. So again, carry on entering your data. This will continue in the background. And then this is the word cloud. So we asked you, in your opinion, what are the top priorities for addressing quality issues within digital pathology? So staining is coming up as quite a common one. Slide preparation. Yeah. So, let us know your pain, let us know your frustrations, put them into the word cloud, and we'll hopefully start to help us, work on what to work on next and what information to share. So thank you very much. I'll let this go for a little bit longer, and you can watch it grow, and then in another minute I can then hand back to David and any questions.
Thank you so much. Well, I really appreciate it. Sorry if I mispronounce NPIC. Actually, I know the acronym because I ended up on Sierra topic. And so, but acronyms, you don't know unless someone is telling you. And wow, I work on this, and it's like just a couple of months, and I have faced many of the issues we were talking about today. And so I do agree this is a huge topic, and it's important that anyone could be more conscious, because we need the contribution of anyone to have like a common ground, especially because we are not facing just one side, but it's like a very complex problem with overlapping of varieties of different things that can have a real true impact. What I can say from my point of view, what surprised me so much is that my first feeling, like my human perception struggles with all this gap. And then I realized I'm not the only one. The AI is having a lot of issues about it as well. So we can demand like, oh, you know, there's a computer, it's perfect, it's not an issue. No, it is indeed. So if anyone has some questions, I'm sure we will have a lot of answers.
While we're waiting for questions, I guess.
Please raise your hand when you want to ask a question. I need to unmute you, I think.
Yes. Oh, we have a question here from Moritz for Katrina. Well, actually, for you all. Would you, by any chance, be able to share some of the polymer film you use for creating the test objects for a small experiment, or tell us what polymer it is? Or would you even be interested in a cooperation on a small test? Plus, can we buy the gray filter and resolution test objects? And also the stain QC dot slide. We have some interest here.
So I think it's for me to answer that question. I can see Hayley and Kat looking at me, sort of asking me to answer that one. So absolutely, we will be very, very happy to cooperate. Sending samples out is difficult. We do have patents on these technologies, and we are hopefully developing them as a commercial tool. We are hoping to make them freely available to NPIC. We didn't mention we're going to do NPIC and Bigpicture. We are going to be doing a UK-wide study, and we will happily replicate that in Bigpicture as well. So there will be an opportunity. But if you have a specific subject topic you're interested in, please do reach out to us, Moritz. We would be very happy to. The grey filter resolution test objects, they are imminent as well. We have there is some IP in them which wasn't shown today that we need to make sure is just finalized before we can share, and they will be commercially available. We have a small stock already. They just need this IP issue to be worked through, and also the stain QC dot slides. I don't quite know what you mean by that one. I think that was just an amalgamated slide of Kat's.
But Moritz, I know we talked at the annual meeting, so I've got your name down already to get in touch and send you some things. So we haven't forgotten. It's just time is flying.
I think in the meantime, I enabled a speech for everyone, so you can unmute yourself when you want to raise questions.
Okay, we have answered to Moritz. I really loved also the map, like in Risico. You are projecting to expand your area. First Great Britain, then the world, then the universe.
We are doing, like David said, some things within Bigpicture, and there is a task force. So if anyone is a beneficiary or part of Bigpicture and wants to know more, reach out to the PMO team, and they can get you to find out more about the task force if you want to join, if you just want to be kept up to date. Reach out to them and they can put you in contact with us. Oh yeah, I forgot we had slides for that. There you go. Or even a link. And let me see, I'll put that in the chat as well. But yeah, the task force is cross work package, and it's, the work you've seen today is just NPIC, but for the task force we're reflecting work that's been done across different consortiums, and Gaia's work in Janssen as well. There's all sorts going on. Yeah, so it's but it's all about quality.
Yeah, well, it's not a tiny thing, quality. I mean, it's the focus of everything.
So we have another question from Anna, and Anna, yes, we absolutely are doing more scanning tests in Bigpicture. We have completed a pilot.
Yep.
We have the feedback to those who participated in the pilot. We had some technical issues, but that now will be completed, and then we will be doing this routinely. So there will be a pattern, I guess, of sharing the Sierra slide amongst the Bigpicture participants, and then we will get some really nice data.
Yeah, I recently talked about it as well. It is one of the issues I've been stepped in, and definitely I ended up embracing the Sierra concept. I'm in love with it, and I deeply push it.
So another question about the Tango slide.
Mm-hmm.
So what we're planning to do, and I think it's fair to share, is we are producing a number of Tango slides, because obviously once you've used the slide, then it's a simple one use. We also have a tool for reading those slides. What we are going to do is a national study in the UK. When we have completed a national study in the UK, we will repeat that with the Bigpicture, and we will be making these available to everybody, all the slide contributors in Bigpicture. We will happily share the Tango slides, and we recognise that's quite a big thing, and we need to get that through the process and make sure it's all done properly, as we did with Sierra. So it won't be quick, I don't think, because we need to make sure that's all done with the anonymity, etc. But it will be available if those wish to do it.
So I think we are running out of time, ma'am.
Yep.
So I don't know whether there are any pressing questions.
I think they are overloaded. Like, oh my God, I can't trust anything anymore. That's what I felt when I started working on quality. And thank you so much. I didn't know as well about Tango, so I also have another step in all the process.
Thank you, and I'd just like to say thank you for letting us speak today. It's been it's obviously a team effort. There's many people in our team. Only a few of us here today speaking. I see another member of our team is actually joined as well. Hi Keith, hope you have a nice holiday. So just to say, there's a whole range of people, and I'd just like to say thank you to all of them as well for supporting our efforts.
Yeah, we are. Well, there's a lot of compliments. I definitely agree. It was super interesting, and it's crucial. We can't think about having a repository without a standard for quality, and we can't have a standard in our mind if we are not all together very determined in achieving it. It requires time, it requires money, effort, energy, people, time, but that's the way. Otherwise, we are collecting data and images that are actually of poor value. So what's the point about having something that you can't actually use? And to be able to actually compare images is the real target that we have. We will have final users, and we have to be sure that they will be able to have all the information for this slide. So yes, quality is definitely the thing. So, yes, we are running out of time. So
yeah. So thank you very much for presenting and for chairing, all of you. So it was very interesting, and have a pleasant weekend, I would say.
Yep.
Thanks, everyone.
Bye, everyone.
Thank you very much. Have a good weekend.
See you.